Alright. So first we will start with identifiers. What is an identifier? Identifier is the name given to any program. Name given to any part of program using which we identify it. Using which we are going to identify it. So from identifying the name comes identifier. So identifier is actually the name of a class or the name of a method, or it's the name of a variable, name of a constant. Any such name by which we identify any part of the program is an identifier. It can be name of a class, name of any method, variable, constant, anything. Any name that will be an identifier. Right. So there are certain rules for writing the identifier. What are the rules for writing an identifier? First and foremost rule is that it should be between capital A to capital Z or small a to small z, 0 to 9, right, underscore, right. Then nowadays even dollar is being used, or currency constant, right. This is valid in English, right. So the name can be any valid name in between these character sets, or you can also use any Unicode language character set. Means basically you can use alphabets of English character set, or you can use of any language, Unicode language character set. For example, you can use Arabic, French, you can use all these languages. So basically first we'll be concentrating on this only, right. So you can use underscore, currency constants, no special characters allowed. No special characters allowed. Right. Second point is that it should begin with character, or it should generally begin with a character or underscore. It cannot begin with a number. The name cannot begin with a number. Right. The name cannot begin with a number. It cannot begin with a number. Right. It can have any length, whatever the length may be, you can choose. It should not be a keyword. It should not be a keyword. Now, what is a keyword? What is a keyword? A keyword is a word that already has a meaning in the language. That already has a meaning in the language. It is already having a meaning. A predefined word in a programming language is known as a keyword. Example: if, else, loop, for, while, class, and these are the keywords. So a predefined word in any language is a keyword. It is a keyword. Right. Now a keyword, fine. Example, if you can just see example, if, else, for, while, do, etc., etc. Java currently has 52 keywords. Right. It supports 52 keywords. Right. Correct. Then no white spaces. White spaces are the blank spaces. No white spaces allowed in between the identifier. You should not use any white spaces. So example, some of the valid identifiers. Some of the valid identifiers are Shiva 9 underscore Shiva. Right. But 9 Shiva is incorrect. This is incorrect. This is not correct. Right. So these are some of the valid identifiers that are present in that we can write in Java. Right? Okay. Fine. Now we talk of another point. That second is literal. What is a literal? Literal is simply, actually literal deals with variables. Literal is something that is dealing with variables. Right? So literal deals with variables. What is a literal? A literal is a value. It is a value that is given to a identifier. Literal is a value that is given to a identifier. Right? In fact, identifier variable. The value, that value is known as literal. The value is known as literal. Example, if we are giving int x is equal to 10, this is a literal. 10 is a literal here. 10 is literal and x is identifier, and x is an identifier. 10 is a literal and x is an identifier. Right? Similarly, whatever you can take, this is what is literal. These literals can be divided into various data types. So Java divides the identifiers, or whatever you call identifiers, into various data types. It divides it into various data types. So various data types in Java are, we need to study about the various data types that are present in Java. Okay, you can just see this. Okay, so basically talk about the data types, correct? And you can just see here. Right. Fine. So data types can be broadly categorized into two types. First is your, we can say, primitive data types, right? Also known as basic data types. We also call them basic data types, right? And another is your complex data types, or also known as reference data types. Complex data types, and we also call them reference data types. Also call them reference data types, right? What are the data types that are present in basic and primitive data types, right? These are basically integer, or we can start with short, byte, int, long. Then we have is float, double. You can go with. Then we have is boolean, right? Float, double, boolean, and character. These are the 8 primitive data types that we have. Reference are basically the object-oriented data types, right? These are the object-oriented data types, and we can take here is any class types and objects. That is the user. These are also user-defined data type. Means user defines a class himself. We can also call them. These are the user-defined data types. User defines them. And we can also go with, these are the class types and objects, user-defined data types. Then we may go with is arrays, right? And all these things. These are the complex data types. So this is basically simple data types that we have, and these are the complex data types that we have here. Okay. So first we are going to make a study about the primitive data types. Let's just study about primitive data types. So what are primitive or simple data types? Primitive or simple data types. What is this? So basically a primitive data type is simple data type. Why it is known as simple? Because I'll just explain you a reason for it. Because actually everything in Java is an object. That is, everything in Java is in form of a class. When we want to use that, we need to make its object, right? So everything in Java is defined in form of a class. In form of a class. When we need to use them, we need to make its object. When we need to use them, we need to make its object. So whenever we want to use them, we need to make its object. So everything in Java, we can say, is object oriented except one thing: primitive data type. So you can say everything is an object in Java except the primitive data types. Everything is an object in Java except the primitive data types. Everything is an object in Java, right? Okay, just primitive data types are not objects. Why primitive data types are not objects? We need to understand this. Why primitive data types are not objects? Why they are not objects? The reason is that since objects occupy more memory, exactly, objects occupy more memory, and in a project we make many primitive data types. We make many integers, float, and all those things, right? So if they would have been objects, then they would have occupied more memory. So make the program more lightweight and make the program more efficient performance wise. The Sun Microsystems had made the Java the primitive data type as non-object, right? Since primitive data types are used frequently, they are used very frequently. So we can simply so they have not been made object, so that programs will have more efficiency and will occupy less memory right? Since they are used frequently, so they will not be, so that programs will have more efficiency and occupy less memory. Correct. So let's discuss about these primitive data types now, right? You should remember one thing, that primitive data types are not objects. So primitive data types, okay, now broadly they can be divided into, primitive data types can be divided as, first is integer part, second is they are having the we can say integral or numerical, right? Numerical, then you have the float part, and third is boolean, and fourth is character. Broadly they are categorized into, but they are having subtypes also, right? Broadly they do have subtypes. First we begin with integers. First I talk about integers. So an integer, right? So integer is divided into 4 types. There are 4 types of integer in Java, right? There are 4 types of integer in Java. What are those 4 types? They are, first it begins with byte, short, int, and fourth is your long. We have byte, short, int, and long. These are the 4 different types of integers that are present. Why integer has been divided into 4 different parts? Why? What is the reason? The main reason for dividing into 4 different parts is that user can choose, these all occupy separate memory. Okay? All these types occupy separate memory. So when user is programming, user can choose a data type as per his requirement, right? User can choose a data type as per his requirement, and if he needs a small number, he can choose a small data type. He does not need to use integer, right? So basically for that reason, and that will definitely save memory for the program, right? So that user can choose the data type as per his requirement, right? Correct. So let's see what is the size and requirement of these data types. Size and requirements are, you can just go for something as, just explaining here, you can just make a small table here. So first is byte. then of course you have short, of course you have int, and you have is long. Generally integers are of two types. In C and C++ you might have noticed integer of two types, signed and unsigned. Integers are of two types. These two types are, first is signed integer and second is unsigned integers. We have signed integers and we do also have the unsigned integers. What is the difference between signed and unsigned? Actually there is a hell lot of difference between signed and unsigned, but in very short term you can just say signed integers are those integers that are capable of representing positive as well as negative numbers. So signed integers are capable of representing, they are capable of representing positive and negative numbers. Unsigned integers, they can represent only the positive numbers. Okay. In Java there is no signed and unsigned, there are only signed integers. In Java there are no unsigned integers. That is, all integers are signed and they can represent positive as well as negative numbers, and they can represent positive and negative numbers. Right, now if we just see here, we have byte. First we talk of the size. So byte is having basically 1 byte, its size is 1 byte, it means 8 bits, right? It is having 2 bytes. Integer is with 4 bytes and long is with 8 bytes. 1 byte is 8 bits, right? Now what is the range? Now generally range, the formula to calculate range for integers is 2 raised to the power n minus 1 minus 1. The formula comes here, it's 2 and it's raised to the power n minus 1, where n is number of bits. This is minus 2 plus, just copy it, 2 n minus 1 minus 1. Now this is not in raised format, so it will be like this. So if suppose it is having 8 bits, this is having 8 bits, so its range becomes minus 128 to 127. Minus 128 to 127. This is what the range is. Minus 128 to 127. Similarly, for this one also, you can simply use a calculator for calculating this. So it is basically 16 bits. It will be of 16 bits. Okay, so you can just use a calc. So if you just see, so it will be minus 2 raised to the power 15 to plus 2 raised to the power 15 minus 1. So 2, and you can just, it will be 2 raised to the power 15. So it's 32768, 232 minus 32768 to 32767. So just see, minus 32768 to 32767. So you can use the same formula for calculating the ranges, right? So similarly we can calculate the range for this one also and simultaneously for this one. Now what if we provide a number beyond the range? What will happen if we provide a number beyond the range? If we try to provide a number beyond the range of integer or any data type, it gives an error, possible loss of precision. The error is possible loss of precision, right? Okay. Found, जो भी आपने लिखा होगा, found ABC, required whatever it requires it, required whatever it requires it. This will be the error that will be thrown. Possible loss of precision. Now if you just see, we'll see here byte B is equal to 127, right? And with just to print anything on the screen, we can use system dot out dot println and B, and it's correct. I'll go for 129. See, it gives an error in ID only. And if you see, possible loss of precision, required byte found int. Possible loss of precision, required byte and found an integer. Right? Okay. So similarly for short also, range of short is this. This is the range of short that is present. Similarly for integers also you can calculate the range, and long also you can calculate the range. Right? Everything is fine, but there is one special thing about long. What is about long? A long literal should be written with a suffix, that is small l or capital L, small l or capital L. Example, if it's 1, 2, 3, 4, 5, 6, 7, 8, 9 L. If we do not write L, before the long literal, it will give you an error. It will not recognize it as long. It will recognize this one as integer. If we do not write the suffix L, it will recognize it as integer and not as a long value. It is not going to recognize it as a long value, but it is going to recognize it as an integer value. So we should write small l or capital L. Just if we see an example here, long L is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 1, 2, 3, 4, 5, 6. I just write it. Now if you just see, integer number too large. The error is integer number too large. Why integer number too large? Because with its value I have not written L. So since I have not written L, it is treating as an integer. If I just write L here, it's correct. It's completely correct this time. And system dot out dot println L. L. Just when you run it, it's the number. But if you just remove it, it is going to give you an error. So long should be written with small l or capital L. It should be written with a small l or capital L. Now similarly, an integer is written with int x is equal to 134, and you can just print this integer x. Right? So 1, 2, 3, 4. Now fine. Alright. Now basically there is one important point, that integer literals can be converted into octal and hexadecimal. We can convert them into octal or hexadecimal. How can we convert them into octal? If we write 0 before integer literal, it will be treated as an octal number, right? So if we write 0 before the integer literal, it's treated as an octal number. It's treated as an octal number. And if we write 0x before a integer literal, it's treated as hexadecimal. It is generally treated as an hexadecimal number. We treat it as an hexadecimal number. It is integer or hexadecimal. Just we can see an example for it. So if its int x is equal to 034, got this, and system dot out dot println x, we get this 28. 34 is automatically converted to 28. How is this happening? We are converting a integer into, now if it's 34, we go to 34 4. So it should be converted back into your this is actually in octal format. We need to convert it into integer format. So octal should be converted into integer. So we can easily do it as we can just write it 8 raised to the power 0, 8 raised to the power 1, and you can just add them. 8 raised to the power 0 is 1, 8 raised to the power 1 is 8. So 8 into 3 is 24 and 1 is 4. So it begins as it is 28. So it is 28. 24 plus 4 is 28. Right. So here octal is being converted into simply the decimal format. Now similarly, a hexadecimal. If I just go for 0x, so this time the answer is going to change. It's 52. So let's see how it's 52. So it can be easily 52, as you can just go for, again it's 3 and 4. So it's 3 and 4. So we can just go with 3 and 4. I can just go with 16 raised to the power 0 and 16 raised to the power 1, right? So it will be 1 and 4, 4, 16, 1, 16, 3, 48, right? So 48 plus 4 is equal to 52. It is equal to 52. 48 plus 4 is 52. Right. So 0x is treated as hexadecimal and it is treated as, right? So we need to write it, this, I'll just write it here. So this is the table that you need to follow for integers. This is the range, and of course it should be written with small l or capital. We should write it with L or capital L. We should write it with small l or capital L. Next thing we need to discuss about the floats. Alright, so now we continue with floats. The decimal values, right? So floats are basically of two types in Java. First is the float and another is your, we have double. Now float is of 4 bytes and double is of 8 bytes. Float is 4 bytes and double is 8 bytes, right? So basically, what is the main difference between float and double, right? What is the difference between float and double? So we can just write the difference between float and double as, so floats will be, float first and foremost thing, floats are written with the suffix f or capital F. It is must to write them with a suffix, right? For example, it will be example, if you see, it will be 34.5 f. 0.5 f, right? And doubles are not written with, you can write them, it is optional to use D or capital D, but if you do not write, they won't give you an error. But if you do not write float, this is mandatory, this is optional. If you do not write float with a F, they will generate an error. This is mandatory and this is optional. This is completely optional, mandatory and optional. So basically, and another point is of, another difference is of precision. Precision means number of digits after the point. We all need is precision. If you want to measure light, then we cannot measure light with precision of 2 digits, right? If you want to measure any if you want to do any scientific calculation, it cannot be with the precision of 2 to 3 digits. We need 7 to 8 digits. So generally this precision is 7 digits, and here the precision is 15 digits. As the size, the precision also changes. The precision is 7 digits and it is 15 digits. If you just see an example, you can just go float f is equal to 34.5 f. F. If I do not write it with f, compiler will confuse it with a double, because double is a decimal that is not written with any suffix, right? So it is confused, and you see the error. It is saying possible loss of precision, required float and found double. So it is assuming it a double, and you are providing a double value to a float. So this is an error. So you should write with f, and just you can go with system.out.println f. System.out.println f. Very simple. Just you can run it. 34.5. You can easily see this. Right. Similarly, we talk about doubles. So double d is equal to 34.5. It can be written normally, and simply we can print system.out.println d. You print it, it's 34.5. Right? Let's talk about precisions. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go with 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Let's see what is the precision we are getting. If you see, it is 4, 5. It's up to 6 actually. Right? 4, 5, and it's rounding up. And here it's 6 here. It's 15 here. Right? Okay. So it's 9 and more 6. So it's up to 15 digits. Right? So this is the difference between float and double. Right. Next we have is Boolean. It's very simple. Boolean is simply of 1 byte. And Boolean can accept only 2 values. It can accept only 2 values. True and false. One very important point. 1 and 0 integers are not treated as Boolean in Java. Java is very strictly typed language. Integers, for example in C and C++, 0 is treated as false, and any positive number and any non-zero number is treated as true, in fact. Right? So integers are not Boolean in Java. If you try to write this Boolean b is equal to 1, it's completely wrong. It is completely wrong. Java is strictly typed language, and it clearly differentiates between integers and Booleans. So Java is strictly typed language. It clearly differentiates between the Booleans and integer. It differentiates between Boolean and integer. If you just see here, Boolean b is equal to true. If we try to do Boolean c is equal to 0, see, it's an error. This is an error. It's clearly an error. It says required Boolean and found it, incompatible types. Right? So we cannot use integers as Boolean. You can simply go for system.out.println b. Alright. So Boolean can hold only 2 values, either true or false. That's it. Nothing else. No other value Boolean can hold. Right. Next is characters. Eighth is characters, eighth data type. A character is written as char. Character is written in single quotes. Character is only single character. It is written in single quotes. A string is written in double quotes. Right? A character is written in single quotes. It is written in single quotes. Right? Size of a character is 2 bytes. Size of a character is 2 bytes. Right? Why size is 2 bytes? Why? In C, it's 1 byte. So, someone can argue with you that we are wasting memory in Java, but it is not the case. Internally, computer only understands integers. It does not understand characters. It won't know what is A, what is B. Internally, all characters are converted into integers. Right? So, internally, all characters are converted into integer. Right? Internally, all characters are integer. So, in C, so we can assume them as integers. In C, it was 1 byte. It was 1 byte. So, 1 byte size can hold only 256 characters by formula minus 2 to the power n minus 1 to 2 to the power n minus 1. 1 byte, that is 8 bits, can hold only max 256 characters. They can represent only 256 characters by formula. Right? They cannot represent beyond that. In 256 characters, only English character set can be represented. English character set plus special symbols and all the keys of your keyboard. Right? In 256 characters, only English character set is represented. So C supports only English character set. Right? So hence C supports only the English character set. It supports only the English character set. Right? It follows ASCII notation. It follows ASCII notation. It is a notation that converts character into integers. That provides a integer value for every character. Behind every book, you will definitely find a table of ASCII notations. It is simply, C follows ASCII notations. What is ASCII? ASCII stands for American Standard Code for Information Interchange. That is, ASCII notations convert the character into integer. They convert the character into integer. Right. Okay. But Java supports 17 international languages. Java supports 17 international languages. Right. Java here supports 17 international languages. So it should include all the characters of all the languages. If you want to write a program in Arabic, you can write it. So it should have Arabic character set also. Right. So it should contain Arabic and all languages character set. All languages character set. All languages character set should be present here. And all these languages character set are present because in Java character is of 2 bytes. Hence, in Java a character is of 2 bytes. Thus, 2 bytes means number of characters it can hold is approximately 6553635. Means 36 you can say 0 to 65536. These many number of 65,000 characters it can hold. Right? So in this number, all all the languages character set are present, right? So since it supports all languages character set, so hence in Java the character is of 2 bytes. It is of 2 bytes. And it does not follow ASCII notation. It does not follow the ASCII notation because ASCII is only for English character set. Instead, it follows another notation that is known as Unicode notation. Unicode notation contains an integer value for all the international languages character set. Right? So it follows Unicode notation. Unicode stands for Universal Code. It has code for all the international languages. It contains code for all the international languages. But if you know ASCII notations, there is one good thing. 0 to 255 in Unicode are also English characters. 0 to 255 in Unicode are also English characters. So in Unicode also 0 to 255 are English characters. They are simply the English characters. If you remember ASCII notation, then you can easily use them also because most of the people are using English only, right? So example, for capital A notation is 65, numerical is 65, numerical notation. For small a it's 98. For small a it's 98. The numbers remain same in ASCII and Unicode. Right? So these numbers remain same. These numbers remain same in ASCII and Unicode. If we just go for an example, you can just see here. Character C is equal to A. Let's say A. Okay. Now if I just go for system.out.println C. Now if I just run it, it's A. But if I just print its integer value, I can print it like this. This is known as typecasting. Converting one data type into another data type. I'll discuss this topic in future, but this is a very short topic and this is simply used for converting one data type into another data type. So I'm converting character into integer. Right? So it's 97 here. So it's 97. Similarly, if it's capital A, it will be 65. It's 65 here. For capital A, it's 65. So this is how internally every character is treated as an integer only. All of them are integers basically, right?